Hello, welcome to the review lesson on solving quadratic equations. In this lesson, we're going to focus on solving quadratics by factoring, square roots, and the quadratic formula. If you want to look into other methods of solving quadratic equations like completing the square, you can go ahead and look on the resource page and access those videos topic by topic. If you have any questions when we're all done, you can go back to the main lessons page, scroll down and add a question to the chalkboard on that page on the website. All right, so let's go ahead and get started with solving quadratic equations. First, we're going to focus on solving quadratic equations by factoring. So in order to solve quadratic equations by factoring, you need to know what the zero product property is. So the zero product property says that if A times B is equal to 0, so two numbers multiplied together equal 0, then either A has to equal 0 or B has to equal 0. So the concept here is if I can get a product equal to 0, it has to be 0 times b equals 0 or a times 0 equals 0 in order for it to be true. So let's take a look at an example of using the zero product property to solve the quantity of x plus 2 times the quantity of x minus 8 equals 0. So by the zero product property, it says that one of the two quantities, either x plus 2 or x minus 8, has to equal 0 in order for their product to be 0. So I'm going to set x plus 2 equal to 0 or x minus 8 equal to 0. So to solve x plus 2 equals 0, I'm going to subtract 2 from both sides, and I get x equals negative 2. To solve x minus 8 equals 0, I'm going to add 8 to both sides, and I get x equals 8. So for my answers, x can either be negative 2 or 8 for this equation to be true. So if I plug in negative 2 for x, I'm going to get negative 2 plus 2, which is 0, times negative 2 minus 8, which is negative 10, but 0 times negative 10 is 0. So we can see that negative 2 works. Now if I plug in 8 for x, we have 8 plus 2 is 10, times 8 minus 8, which is 0, 10 minus 0, or 10 times 0 is 0. So we can see that both of those solutions work. All right, now just as a review, we're going to take a look at standard form. Of a quadratic is ax squared plus bx plus c is equal to 0. Now, when we solve by factoring, we do want it to be in standard form. So we want to have it equal to 0 on the left-hand side. So here we have x squared plus 4x minus 12 equals 0. This is in standard form, so we don't need to make any adjustments, but we always want to check that as we begin. Now we're going to use the X method to factor. This is just a way of organizing your work. So when we factor, we want our two numbers to multiply to the constant, which is negative 12. So I'm going to put that up top. So I want to multiply to negative 12, and I want to add to the center value. So the value in the middle is positive 4, so I want to add to positive 4. So I'm thinking of two numbers that multiply to negative 12 and add to negative 4. Now I know to multiply to a negative, one of them has to be positive and one of them has to be a negative. So a positive times a negative equals a negative. So I'm thinking positive 6 and negative 2. I'm just going to check. Positive 6 times negative 2 equals negative 12, and then positive 6 minus 2 is equal to positive 4. So these are the correct values. These values, positive 6 and negative 2, are not my answers. These are the values that are in the binomials once I factor. So the trinomial x squared plus 4x minus 12 equals 0 becomes the product of two binomials, x plus 6 times x minus 2. Now if I were to take these two binomials and multiply them together, I would get x times x is x squared. X times negative 2 is negative 2x, 6 times x is 6x, and 6 times negative 2 is negative 12. When I combine those like terms of negative 2x and positive 6x, I get positive 4x, and I see that I get that original trinomial. So when we factor, we keep the equation equivalent, it just changes the look. So now I'm going to use that zero product property and set x plus 6 equal to 0 or x minus 2 equals 0. To solve for the first value of x, I'm going to subtract 6 from both sides, and I get x is equal to negative 6. To solve for the second value of x, I'm going to add 2 to both sides, and I get x is equal to 2. So my solution is x equals negative 6 or 2. Let's take a look at another example where we solve by factoring. We have x squared minus 3x equals 10. This is not in standard form. I want all the terms on the same side, and I want 0 on the right. So I need to move 10 to the other side by subtracting 10 from both sides. When I do that, I get x squared minus 3x minus 10 equals 0. Now to factor, I want to multiply to the constant, and negative 10, and I want to add to the term in front of x, which is negative 3. To multiply to a negative, it has to be a negative times a positive. To add to a negative, I need my larger number to be the negative. So when I think of 10, I think of 5 and 2. So I'm going to try negative 5 and positive 2. I know that negative 5 times positive 2 is equal to negative 10. Negative 5 plus 2 is equal to negative 3, so these two numbers work. They're going to be the numbers inside of my binomials. So we have x minus 5 times x plus 2 equals 0. So to use the zero product property, I'm going to set x minus 5 equal to 0 or x plus 2 equals 0. To solve the first one, I'm going to add 5 to both sides, and I get x is equal to 5. To solve for the second value of x, I'm going to subtract 2 from both sides, and I get x is equal to negative 2. So my two possibilities for x are either 5 or negative 2. Another example, solving by factoring. Negative 3x squared equals 18x plus 27. Again, this is not in standard form. I want it to equal 0 on the right-hand side, so I'm going to move 18x and positive 27 to the other side by doing the opposite. I'm going to subtract 18x minus 27, and I'm going to subtract 18x minus 27 from both sides. That eliminates the two terms on the right and moves everything to the left. So on the left-hand side, I have negative 3x squared minus 18x minus 27 equals 0. Now, factoring is much more simple when we have a coefficient of 1 in front of the x squared. So what I'm going to do is take a look at the three terms and say, is there any way of factoring out that 3? So my first term is made up of a negative, a 3, and two x's, x times x. My second term is made up of a negative. 18 is made up of 2 times 9. 9 is made up of 3 times 3, so 18 is 2 times 3 times 3. And then I have a single x value. And then last, my negative 27 is made up of a negative. 27 is 9 times 3, and 9 can be broken up into 3 times 3. So what we're doing here is looking at the prime factorization of each of the terms. What are they made up of in their most simple elements? So if I take a look at that first oval, negative 1 times 3 is negative 3. X times x is x squared, so I get negative 3x squared. That's my first term. For the second oval, I get negative 1 times 2 is negative 2, times 3 is negative 6, times 3 is negative 18, times x is negative 18x. So when I multiply everything together, I get my terms. Now what I want to do is focus on what do they have in common. Well, each of them have a negative 1, and each of them have 1, 3. So I'm going to pull out negative 3, and what's left over is x squared for my first term, 6x for my second term, and positive 9 for my third term. So now I'm going to focus on factoring that trinomial inside the parentheses. So I want to factor x squared plus 6x plus 9. So I want to multiply to the constant, 9, and I want to add to the b, the value in front of x, which is positive 6. Both are positive, so both of my numbers are going to be positive, and I'm going to look at 3 and 3. So 3 times 3 is 9, 3 plus 3 is 6, so that works. So we're going to have negative 3 from what we factored out originally, times the quantity of x plus 3 times the quantity of x plus 3 equals 0. So my zero product property, I actually have three options. I have negative 3, x plus 3, and x plus 3. Now my x plus 3 is really the repeat, so I'm going to look at two parts. Negative 3 equals 0 or x plus 3 equals 0. Now negative 3 does not equal 0, so that doesn't tell me anything about my x value. I'm going to look at x plus 3 equals 0 and solve for x by subtracting 3 from both sides, and I get x equals negative 3. There's no other solutions, so it has a single solution, x equals negative 3. All right, so now let's go ahead and take a look at solving quadratic equation by square roots. So quadratic equations are equations that have x to the second power, and a square root is the inverse of a square. So it would make sense that we can solve by a square root. So let's take a look at what a square root is. Now I know that 5 squared is 5 times 5, which is 25. So if I want the square root of 25, I'm asking myself what number times itself equals 25, and the answer is 5. So the square root of 25 is 5. Now if I look at negative 5 times negative 5, that's also equal to 25. So what we have to do is take into account that there's also this negative aspect to the original question. So let's make a note here. That when using square roots to solve equations, you must find both the positive and negative square roots. So plus or minus square root of 25 is equal to plus or minus 5. All right, so let's take a look at solving equations using square roots. If I have x squared is equal to 25, to undo a square, I want to take the square root. So I'm going to take the square root of x squared, and what I do to one side, I have to do the other, remembering to do the positive and negative version of the square root of 225. Now I'm asking myself, what number times itself equals 225? And if we think back to our perfect squares quiz, I know that 15 times 15 equals 225, so x is equal to plus or minus 15. Now if I'm looking at 36 equals x squared, typically we like our variables on our left-hand side, so I'm just going to go ahead and flip that around and have it x squared equals 36. Now in order to undo a square, I'm going to take the square root. What I do to one side, I do to the other, remembering that we're going to do plus or minus square root of 36. So square root of x squared is x. The square root of 36, what number times itself equals 36? That is 6, so we have plus or minus 6. Now if we're looking at the x squared equals negative 100. I want to undo the square by taking the square root. What I do to one side, I need to do to the other. Now, as of right now, taking the square root of a negative number is not possible. We don't have the knowledge yet to figure out what that value is. So taking the square root of negative 100 is not possible as of right now, so we say no solution. What we really want to say is that there's no real solution. In the future, in Algebra 2, you guys are going to learn about a set of number called imaginary numbers, and that makes that problem possible. So as of right now, no solution. And just follow it with a ... to be continued. All right, so our next example, solving using square roots, we have 3x squared equals 75. Now, if I want to cancel the x squared, I want to take the square root, but I really want x squared to be by itself. So the first thing I want to do is get rid of the 3. So to undo the multiplication, I'm going to divide both sides by 3, which gets me x squared equals 25. Recognizing that 25, that looks good. So I want to take the square root of x squared to cancel the square root of 25, remembering both the positive and negative. So square root of x squared is x, and then we have plus or minus square root of 25 is 5. Our next example, we have 0 equals 81x squared minus 25. Now, I like that 81 because I know that that's a perfect square. It's a 9 squared. And I like 25 because I know that 25 is 5 squared. So if I can somehow take the square root of these, I know I'm going to get whole numbers. So what I want to do is first get x squared by itself and then look at taking the square root. So to get x squared by itself, the first thing I'm going to do is I'm going to flip this around so that my x squared is on the left-hand side. So I have 81x squared minus 25 equals 0. Now I'm going to go ahead and add 25 to both sides. So that's my first step in getting x squared by itself. So I get 81x squared equals 25. Now let's divide both sides by 81. So I get x squared equals 25 over 81. Don't worry about those fractions. We're going to be just fine. Now I want to cancel my square, so I'm going to take the square root. What I do to one side, I have to do to the other, remembering my plus or minus in front of the square root. Now remember what we did with the distributive property. Anytime we have a fraction inside of the radical, we're going to distribute the radical to the numerator and to the denominator. So I'm going to take the square root of 25, which is 5, and then I'm going to take the square root of 81, which is 9. So my answer is plus or minus 5 over 9. When I say plus or minus, that means the positive value, positive 5/9, and the negative value, negative 5/9. So there are two different answers there. Okay, so now our last example, looking at using square roots, we have 49x squared plus 64 is equal to 0. Again, I'm looking at 49 and I'm like, yeah, that is 7 squared, that's cool. And then I look at 64 and that's 8 squared. So taking the square root at some point in time of those two numbers is totally possible. So let's go ahead and try and get x squared by itself so that we can do that. So my first step is subtracting 64 from both sides. So I get 49x squared is equal to negative 64. Then I want to divide both sides by 49. And I get x squared is equal to negative 64 over 49. So to get x by itself, I have to take the square root. What I do to one side, I have to do to the other, remembering I want the positive and negative value. Again, I see a negative sign inside of the radical, and at this point in time, we're just not equipped enough to solve that. So as of right now, we have no solution for that particular problem. Okay, next we're going to talk about the quadratic formula. So using the quadratic formula, we must have our quadratic in standard form, ax squared plus bx plus c. So the a, b, and c in the quadratic formula are coefficients, which means that they are numbers in front of variables. So for example, if I'm looking at 2x squared plus 4x minus 6, my a value is 2, that's the number in front of x squared. My b value is 4, the number in front of x. And my c value is negative 6, which is the constant. Always remember that whatever sign is in front of the term is whether it's positive or negative. Next, we have 3x squared plus x minus 1 equals 0. Again, this is in standard form. In front of x squared, we have 3, so that's a. In front of x, we don't see a number, but we know there's a 1 there, so that's b is equal to 1. And then c is equal to negative 1. Now, when we have something like 9x squared minus 5, we see that the value in front of x squared is 9, so a equals 9. Now, I don't see an x term at all, so I know that 0x would be its placeholder, but it would also disappear if I actually multiplied by 0. So b is equal to 0 because we don't see it, and then c is going to be negative 5. If I have something like x squared plus 3x equals 4, right now it's not in standard form. We need to subtract 4 from both sides so that we have a 0 on the right. So once I do that, then a would be 1, b would be 3, and c would be negative 4 because I'm subtracting 4 from both sides. For our last one that we're just going to kind of look at identifying a, b, and c, we have negative x squared is equal to negative 7x plus 12. So if I take a look, I want all of my terms to join x squared. So what I'm going to do is I'm going to add 7x to both sides and subtract 12 to both sides. So if I picture doing that, my a, the number in front of x squared, is negative 1. Then if I add 7x to both sides, b becomes 7. And if I subtract 12 from both sides, c becomes negative 12. So you just want to picture getting all the terms on the right and, all the terms on the left and 0 on the right. Okay, so let's practice using the quadratic formula. So the quadratic formula uses standard form, ax squared plus bx plus c, and it is, so I'm going to sing this to you, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So one of the ways to remember it is singing it to the tune of Pop Goes the Weasel. You don't have to. There's also a story that goes with it. And if you're ever interested in hearing it, I'd be more than happy to tell you. But this is the quadratic formula. Knowing the quadratic formula is important because the quadratic formula works every time. Factoring does not work every time. Solving by taking the square root does not work every time. But the quadratic formula works for every single quadratic. So it's really important to know and always have in your back pocket. Okay, so let's look at our first example using quadratic formula. We have x squared minus 5x plus 4 equals 0. So we first want to identify a, b, and c. So a is equal to 1, b equals negative 5, c equals 4. So we're going to plug it into the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So we want to fill in our blanks. We're going to fill in x equals negative b. So b is equal to negative 5, so it's negative negative 5 plus or minus the square root of b squared, negative 5 squared, minus 4ac. A is 1, c is 4, all over 2a. A is 1. Now we just want to clean it up. Out front, we have negative negative 5 is positive 5, plus or minus the square root of negative 5 times negative 5 is 25, minus 4 times 1 is 4 times 4 is 16, all over 2. Clean it up again inside of the radical. 25 minus 16 is 9, so we have 5 plus or minus the square root of 9 over 2. Clean it up again, the square root of 9 is 3, so we have 5 plus or minus 3 over 2. So now we have two different options. We have 5 plus 3 over 2, and we have 5 minus 3 over 2. So 5 plus 3 is 8, divided by 2 is 4, and then 5 minus 3 is 2, divided by 2 is 1. So we have two possibilities, just like with our other quadratics. One of them is 4, the other one is 1. Let's take a look at one more example using the quadratic formula. Here we have 2x squared minus 6. So this is that situation where we don't see an x term. So we always want to remember that when we don't see it, our coefficient is equal to 0. So a equals 2, b equals 0, c equals negative 6. So when I'm filling in the blanks for my quadratic formula, I have x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So my first two blanks are both going to be 0. Then I have minus 4ac. So 4 times a, that's 2, and then c is negative 6 all over 2a, which is 2. So I just want to clean it up. Remember that each fraction, the fraction bar divides it into the numerator and denominator. So order of operation tells us to simplify the numerator, simplify the denominator, and then use it as division. But in order to simplify the numerator, I really need to focus on inside of that radical first. So on the outside, we have 0, plus or minus. 0 squared is 0. Now I'm looking at negative 4 times 2 is negative 8. Negative 8 times negative 6 is positive 48. So I end up with plus 48 inside. So here we're looking at 0 plus minus the square root of 48 over 4. So that separates into two options. Okay, but first, again, we're going to try and look at simplifying our radical. So 48 is made up of 16 times 3. So I have the square root of 16 times the square root of 3. And that becomes plus or minus 4 square root of 3. That comes from the square root of 16 is 4. So 4 times the square root of 3. And 4 divided by 4 is 1, so really this separates into positive square root of 3 or negative square root of 3. All right, if you have any questions about solving quadratics, please feel free to ask on the lessons page or go to the resource page for additional videos on how to solve quadratics in different ways. Thanks.